today's worksheet 7.6, we learned two processes to factoring polynomials if we have four terms or if we have the hard trinomials. And we do this by what we call factoring by grouping. So when I look at number one, how factoring by grouping works is you're always going to take the first two terms and group them together and look at what they have in common. So in this case, I can factor out both a 3 and an x squared. When I do so, I'm left here with 4x minus 3. I do the same thing with the next one, 4x minus 3, and notice that they don't have anything in common other than a 1. So I can go ahead and put that 1. Now when I do this process, the most important thing to note is whatever you have in parentheses has to be the same for both. So sometimes you might have to change the sign. Notice how they are the same. So what I have is 3x squared plus 1 sets of 4x minus 3's. Alright, let's take a look at number 2. Same process. Factor the first two together. What do they have in common? Well, they just have an x squared in common. I'm left with 3x minus 4. Then I take a look at what the next two terms have in common. 9x minus 12 has a 3. I'm left with 3x minus 4. Now notice how these two terms are the same. So I have x squared plus 3 sets of 3x minus 4's. I have number 2 done. Number 3, same process. Ask myself, what do these two terms have in common? Just an x squared. So I have 2x plus 5 left. Then I do the next one, 6x plus 15. They have a 3 in common, left with 2x plus 5, which is good. 2x plus 5's are the same. So I have x squared plus 3 sets of 2x plus 5's. Number 4, 12x cubed plus 4x squared. They share a 4 and an x squared. So I'm left with, 3x plus 1. 6x plus 2, they just have a 2 in common. So I'm left with 3x plus 1. So now I can combine these two together. I have 4x squared plus 2 sets of 3x plus 1. This one's almost done, except these two terms have something in common. They actually have a 2 in common. So I can factor out that 2, have 2x squared plus 1, and I still have this 3x plus 1. So this one had a little additional step because these two terms had something in common. Alright, number 5, x cubed minus x squared plus 4x minus 4. Well, these two terms have an x squared in common, and I'm left with x minus 1. These two terms have a positive 4 in common, and they're left with x minus 1. Combine your outside terms, so we have x squared plus 4, and then x minus sets of x minus 1's. This one would have had to do more if that was negative, but since it's positive, it's not a difference of perfect squares. Number 6, first two terms share a 5 and an x squared. So I'm left with just x minus 2. 3x and minus 6 have a 3 in common, so I'm left with x minus 2. So I have 5x squared plus 3 sets of x minus 2's. Alright, number 7. The numbers get bigger, but the process is the same. What do these two numbers have in common? Well, 9 goes in there, and so does x squared. So I'm left with just, 7x plus 6. Then I ask myself, what number goes into 105 or negative 105 and negative 90? Now this is kind of the tricky part here, or kind of a trick that I do, is sometimes I think, how many 6's go into 90? Well, 15. So I'm going to factor out a minus 15, because if I do, it's going to leave me, 7x plus 6. Remember, these two have to match up. So I kind of use that thought as a way to combine or figure out what I have to factor out. So I have 9x squared minus 15 sets of x, 7x plus 6. However, here's a little trick. 9x squared minus 15 still has a 3 in common. So I have 3x squared minus 5, 7x plus 6. Might happen from time to time where we have to factor out what they might have in common. All right, next one. Ooh, 21 does go into 84 4 times, and I can pull out an x squared. So I get 21x squared, and I'm left with x minus 4. 15 and 60 have a 15 in common, x minus 4. So I have 21x squared plus 15 sets of x minus 4. Sure enough, 21 and 15 do have the number 3 in common, so I got to pull out that 3. And I'm good to go. All right, number 9. 49 minus 35, 49x cubed minus 35x squared, sorry. They have a 7 and an x squared in common. So I have 7x minus 5, 56 and 40. So we need, let's see, an 8. And we get, sure enough, 7x minus 5. So 7x squared plus 8 sets of 7x minus 5s. All right, last one on this page. Factors 28 and 16, they have a 4 and an x squared in common. So I'm left with 7x plus 4. 21 and 12 have a 3 in common. And I get 7x minus 4. Whoops, I should be factoring out, I apologize. Sometimes when I circle it, it's hard to see. I just want to see that was a minus here. So I should actually be factoring out a minus 3. Sometimes when my circles, I can't tell if it was plus or minus. So anyway, combine your terms. So 4x squared minus 3 sets of 7x plus 4. All right, first page is done. All right, second page, we are going to factor each of these trinomials, but I'm going to show you how we do them by grouping. So by grouping it, we have to have 4 terms. We only have 3. So how you go about this process, as we showed you in class today, your first step, multiply the first and last term together. So when I take 3 times negative 5, I get negative 15. So now I need to figure out 2 factors of negative 15 that add up to negative 2. The nice thing is, at least in this case, it is those 2 factors. So what I can do is rewrite negative 2x as 3x minus 5x. It's the same thing. Now I can carry down the other 2 terms, and now I have my 4 terms, and I can factor it like by grouping. Sorry, this should be a plus 3x. So what do these 2 terms have in common? They have a 3x. So now I'm left with x plus 1. These 2 have a minus 5 in common. X plus 1, because I took out the minus 5. Notice how the terms are alike. So now I have 3x minus 5 sets of x plus 1s. Same process on all of these. We'll multiply these 2 terms together first. So 2 times negative 9 is negative 18. So now I need to think of factors of negative 18 that add to positive 3. So I must have 6 times negative 3. Those 2 add to positive 3 if I were to add those together. They multiply to give me negative 18, but they add to give me positive 3. So I can go 2x squared. The 3x now becomes 6x minus 3x minus 9. Now again, as you may have seen in class today, it doesn't matter which term you put first or second. But now it's just factoring by grouping. 2x, so now I have x plus 3. These have a minus 3 in common. X plus 3, since I pulled out the negative. So I have 2x minus 3 sets of x plus 3's. Again, if I'm curious, I can FOIL this back out and check to see if it actually does work. All right, number 3, same process. 3 times 4 is 12. Factors of 12 that add up to -8 are -2 and -6. So I can go 3x squared minus 2x minus 6x plus 4. So these two terms just have an x in common. So I get 3x minus 2. These two terms have a -2 in common, 3x minus 2. So I have x minus 2 sets of 3x minus 2's. All right, number 4. 5 times 12 is 60. Two factors of 60 that add up to 19 are 4 and 15. So 5x squared plus 4x plus 15x plus 12. So I'm rewriting the 19x as 4x plus 15x. So now, what do these two terms have in common? They have an x in common. So I have 5x plus 4. What do these two terms have in common? A 3. So I have 5x plus 4. So now combine your like terms. X plus 3 sets of 5x plus 4's. All right, number 5. 2 times 5 is 10. Two factors of 10 that add up to 11 is 10 and 1. We go 2x squared plus 10x plus 1x plus 5. These two terms have a 2 and an x in common. So I'm left with x plus 5. 1x plus 5, they just have a 1 in common. So I just have x plus 5. So now, combine like terms, 2x plus 1 sets of x plus 5's. Notice how this process doesn't change. 2 times 2 is 4. Factors of 4 that add up to 5, 4 and 1. So 2x squared plus 4x plus 1x plus 2. These two terms have a 2 in common and an x, 2 and an x. So I have x plus 2. 1x plus 2 only have that 1 in common. So I have 2x plus 1 sets of x plus 2's. Number 8. Ooh, big number now. 7 times 28. Ooh, this one's going to take a little bit of time here. So let's actually take out our calculator. Go 7 times 28. 196. So now I need to think of factors of 196 that add up to 53. 49 times 4 is 196, and it does add up to 53. So I go 7x squared plus 49x plus 4x plus 28. So now, what do these two terms have in common? A 7 and an x, so I have x plus 7. These two terms have a 4 in common, so I factor out the 4. So I get 4 sets of x plus 7. So now combine like terms. 7x plus 4 sets of x plus 7's. All right, next one. 4 times -25 is -100. So now I need to think of two factors of -100 that add up to 15. Well, -20 times 5, that would be -15. So I go 4x squared minus 20x plus 5x minus 25. Now, what do these two terms have in common? 4x. I'm left with x minus 5. What do these two terms have in common? just the 5, x minus 5's. So I have 4x plus 5 sets of x minus 5's. Two more left. 15 times negative 6. Let me switch colors at least on these last two. So I get 90. Sorry, negative 90. So I have to think of two factors of negative 90 that add up to negative 27. Negative 30 and 3 will work. So 15x squared minus 30x plus 3x minus 6. So these two terms have a 15 and an x in common. So I have x minus 2, and these two terms have just a 3 in common. So I have x minus 2. So I get 15x plus 3 sets of x minus 2's. Now here's the thing with this one. This one has a 3 in common. So I really have 5x plus 1, and then x minus 2. So 3 times the quantity, 5x plus 1, x minus 2. Alright, last one on this page. 5 times 9, 45. Factors of 45 that add up to negative 18. Both factors have to be negative here. So, this one's going to be a little more challenging here. So let's see here. Could I do 9 and 5? Nope, I got to do, let's see here. Wow, 45? I'm just trying to think, does this one even work? Well, let's see. Wow, I might have had one on here that actually does not work. So 45, let's see, factors of 45 are just 1, 5, 9, and 45. So lo and behold, not factorable. So I must have made a mistake on this. Should have made that negative 14 to make sure that it works nicely. So I'll probably make a note to skip number 10. All right, that ends your homework assignment for today.